All right, so let's just keep going here. This next one, we're going to talk about exponential functions and especially graphs. So, uh, exponential functions, exponential graphs, and uh, for this number e, which is kind of a big deal. Uh, okay, so the computer or looking it up online or whatever, you can get as many digits as you want. This pretty random looking number, we'll talk about what that's all about in some detail later. So most of what we need to do, we already know about, and you've probably graphed exponential functions before, but we want to practice it just a little bit more. We want to connect this, and this is kind of a warm up to some other things that we're going to do, especially when we do the inverse function of an exponential function is going to be a thing. So we're reviewing this now because we're about to mix it with 5.1 when we do future sections. And I also want to, this is a good time to introduce this number e. Maybe you've seen it before already, maybe you already know what that's about. There are a couple of properties that e has, and we'll talk about one of the ways of thinking about the number e right now. So let's just talk about the number e here. So this is something that people figured out quite some time ago, because when it's real money, it's like you start paying attention to detail pretty quickly here. And so how does this work? So you would like invest $1,000 or whatever. I'm gonna make the numbers a little bit big just so it's easier to compute things. Well, the whole point of this is that numbers can be a little bit funny sometimes. How much, if there's sort of this multiplicative nature of interest, and it's like you put money and invest it somewhere, and they're investing it. The idea is they're gonna, they want to lend that money out to somebody that they believe is able to pay it back, and then, well, I give you money, you grow your business does well, you're able to pay me back and then some. So any money you give to the bank is supposed to be able to lend it out, and they're supposed to be able to get back more than you put in. Maybe it's only 3 or 4%, but if it's in this universe where maybe everything is super duper going really well, maybe 10%, let's say. Well, you invest this money, but maybe you want to take your money out early, and the question is, well, how much should you take out? Well, back before people had calculators, this might have been pretty tricky business. Like, how much money should you be able to take out after half of a year? Or do they just say, no, if you gave it to me, I hold on to it to a whole year because that's the contract? It's kind of a question here. So there are a couple questions you can ask here. So 1 year just means 1.1 times $1,000. That's really it. That's just, so that would be cool if you could manage that. And this one is kind of a loaded question. Yeah, this one's kind of, for most, I want to do this just to introduce the concept of E, but what should happen after half of a year? Well, one answer that seems reasonable at first glance, maybe, but it's actually problematic, is this one. It's kind of, you get bonus money because you kind of cheated a little bit. And this is the concept behind compounding interest. So it doesn't look too bad. I mean, if I get 5% interest because it's half of a year, if I get 5% of my money as a bonus, then it's $1,500. But I mean, the problem occurs when, well, one person just keeps their money in the bank for the whole year, and they get the 10%. They're only taking home $1,100. But here, if you kind of cheated, you got your 5%, but then you took that $50 and you invested it on top of the $1,000, and you invested that for another half of a year, and then suddenly 1.05 times. Suddenly you got this extra $2.50 because you bent the rules a little bit, and the bank sort of did you a favor, but when they match up the numbers, then somehow getting an extra 5% of your 5%, some weird stuff happens here. So, let's flip over the board. So what happened? So 1 year, so you got your 10% interest, you only got half of that, but you applied that twice, you got a little bit more. So one time in a year, compounded. This is called compounding. You take that 10% and you divide it into 12 payments, but then you apply that to the $1,000. What do we get? We get 0.1 divided by 12 plus 1 to the 12th power. So that number is getting bigger, but it seems like it's slowing down. So you did this once. If that person comes to the bank every month and asks for their money back with 1/12 of 10%, then they're sort of scamming the system even a little bit more. But how much do they get for their effort? Not a lot. It's kind of silly at this point, but let's go ahead and do it 365 times. Every single day for the whole year. The bank, let's say the bank is open every day and not just 5 days a week, but anyway. It's going to be 11 of something for sure, but let me actually do it. So at 10% interest at 0.1, do it once every day. So every day you gain 0.1 divided by 365, and so you multiply it out that many times the $1,000. And so we do this for 1 year. So what actually happens is there's this magic, well, I don't know, not actually magic, but like, this is what happens if you have an interest rate that's sort of fixed, you know, like say 10%. You compound the interest a very large number of times, like maybe not just 365, but maybe like a million times in a year. You compound the interest into tiny pieces, and the end result is this. So you go to your calculator, you do e to the 0.1 times $1,000. You only get 1 penny better if you, no matter how many times you compound the interest, the most you'll ever get out of that will be 1 additional penny. That's what E does. So it takes the part where you compute the interest, and it looks like that. So this is just to introduce the number E. We'll come back to this, and I'll just write down what the formula is. This only describes what happens for 1 year. If you do this for like 5 years, then you take the interest amount to the 5th power, but this is kind of that number that I wrote on the other side of the board. E is in your calculator. If you ever want to know just plain old E, you have to type in e to the 1st to get E, because most calculators, they have an e to the some power button, and if you just want to know what E is, you have to say e to the 1st. So 2.71828, and then some more stuff. All right, so it's kind of weird, but it's this is the first time that people tend to see the number E. It's not the best application, but there are some that are even more important, but you have to do calculus to get there. So it just depends how much do you like math. If you're enjoying math and you want to go farther, the farther you go, the more you see E, and the more you'll grow to appreciate the various things that it does. It's just kind of, exponential growth is a thing that you can have any base that's bigger than 1 for exponential growth, but one of the very central constructions of calculus has very nice interactions with base E, and it's hard to appreciate until you have to actually do it. So I promise it's a big deal. It's not as this isn't the only thing that E is good for. It's by far, this is just the tiny tip of the iceberg. It's kind of interesting. There's this like, well, you're trying to game the system. You keep splitting things into smaller and smaller pieces. How much can you game the system? How much profit are you getting? Well, you get a little bit of profit and then not a whole lot more, no matter how hard you try. And that's kind of interesting, but it's quite far from being the whole story. All right, so let's just stop it there. That's a nice little self-contained thing. We're going to start graphing some things in the next video.